Hi everyone, welcome back to long division or dividing polynomials. Again, we're in section 3.3. I'm going to do one more long division and I'm going to do one more synthetic division, hopefully to help solidify all those little things. So the first one I'm going to do is we're going to take 8x to the fourth and plus 6x squared minus 3x plus 1. And we're going to divide that whole thing by 2x squared minus x plus 2. Okay, and this one I could not do synthetic division on because I am not multiplying by a linear factor with our leading coefficient of 1. We actually have a squared factor, so x squared term, and we do have a leading coefficient of 2. So we will have to do this one longhand. So again, here we go through another longhand division problem. And sometimes these longhand division problems are nice. In other words, we don't end up with fractions. And sometimes they won't be so nice that you'll have fractions, but fractions are numbers. We can handle that. We could also have really ugly problems. I mean, just imagine if this was the square root of 2 instead of just a 2. So being thankful that most textbooks are nice to you and do stick with the integer coefficients. But the process again is we will take this 2x squared, and what do we need to multiply it by to turn it into 8x to the fourth? And that means we need a 4 and an x squared. And then we carefully have to multiply this by every term in this piece. So we're going to have that 8x to the fourth minus 4x cubed, which I'm going to kind of squish in there. I should have left some space. And then we have a plus 8x squared. Okay. And then we want to subtract. I'm not good at subtraction, so what I do is change my signs all the way through. It's like distributing that subtraction problem. And then I add. So I'll have that 4x cubed and then a minus 8x squared. And then we bring down that next term. Some students will bring everything else down depending on how neat you are. One thing about being in mathematics, sometimes neatness counts. Subtracting, adding things in columns, kind of like an accountant needs to keep all those digits in the right places. We need to keep our exponents all kind of lined up as well. Now we do the process all over again. So 2x squared into that 4x cubed gives me a positive 2x. Multiplying this by every term, 4x cubed minus 2x squared plus 4x. And we do want to make sure that those first ones work. Again, we're going to subtract, so we change our signs. And then I add. These will disappear if we did it correctly. This gives me a negative 6x squared minus 7x, and then bring down my constant term, plus 1. And one last time, because I can still take an x squared into x squared. I will stop when I no longer can take the power up here into the power here. So in other words, when this guy is smaller in degree than what we're dividing by, because then we'll have that remainder. So we will stop if we have a linear factor. All right, so 2x squared into negative 6x squared, probably a negative 3. Negative 6x squared plus 3x minus 6. We are going to subtract, so change our signs, and then we will add. And so this division will lead us to the fact that this divided by this is this guy here, our whole part, is that 4x squared plus 2x minus 3. And then we will get this remainder all over what we were dividing by. And you can check yourself. The way to check is we will take this one and multiply it by what we were dividing, so our whole times what we were dividing, and then add in that remainder. Just like our 7/3 we wrote as 2 1/3, we take 2 times what we were dividing, so multiply those together, so 6 plus the remainder, and we should get what we were dividing into. So if I took 4x squared plus 2x minus 3, multiplied it by 2x squared minus x plus 2, and then added that negative 10x plus 7, we should get the 8x to the 4th plus 6x squared minus 3x plus 1, if we did it correctly. If we have a sign error, then things are off, but we can always check. Okay, I am not going to go and check, but I'm sure you guys have the skills to make sure we did it correctly, so double check for us. All right, I do want to do one more synthetic division problem for you so you can see it again. That was kind of the shortcut way of dividing polynomials. And we are going to take 2x cubed minus 7x squared plus 5, and we are going to divide him by x plus 3. Okay, now remind ourselves how to do this. I like to put the thing we're dividing by in the box, just to kind of keep it separated so it doesn't get thrown away. And remember, it's going to be kind of like the 0 that's sitting in here. So our 0 that we'd be kind of checking is that minus 3. And then we need all the coefficients. So there's our cubed, our squared, our linear piece. We do need this x term sitting in here, and then the constant. So our cube, so 3, 2, 1, 0. And the nice thing about synthetic division, it doesn't use as much paper as the long division. But feel free to do whichever one you like. But I like synthetic division because it's quick and easy. We drop the 2 down. We multiply. We add. We multiply. As long as the numbers don't get too big, I'm okay. We add. And I have a calculator, so I can multiply on my calculator. 39 times 3. Some of you are really good at multiplying in your head. I'm not so much anymore. That's why I use my calculator. And feel free to use your calculators. Except when we're graphing, I will ask a lot of questions as to where the graphs come from, but to help lead through those graphs. So anyway. And then I throw off that last one, and we're going to have to add that 5, so that's a negative 112. This one's ugly. So this divided by this, again, this is your 0, 1, 2, so this is your x term and your x squared term, gives us 2x squared minus 13x plus a 39. And since it's a linear function, I can do the subtraction over that x plus 3. Okay. Thing to remember here is what we were dividing by is not the minus 3, it's the plus 3, so kind of keep that little fact in your head somehow. I always think of it as what we're dividing by as far as zeros go. And this is where we will use synthetic division a lot, is we'll be looking for zeros quickly. Is this number a 0? So I'll just kind of do my synthetic division. Nope, it's not. Move on. Yes, it is. Great. And then we'll go from there. So this kind of concludes dividing polynomials. Again, this is a section that we will be using, but not really, so hence the reason we reviewed it a little bit. But we're not going to really be tested on it. I'll be testing you through the use of it. I hope that makes sense.